Yes, thank you. Thank you. Thank you for being here this late for my talk. What I would like to talk about today are computer using agents. And what I would like to showcase to you is a very, let's say, practical perspective of how we at Softic, can be also SoftIQ, just implement LLMs. So how we actually use LLMs. So we're a software company. We're from Poland, and we don't train models, we don't fine-tune models, we create apps that use models. And I think all of them are pretty cool. I'm going to showcase one of the cooler ones today. It's going to be based on a real production live application that's running for one of our clients. I'm going to also give you this short story about the client, and the whole thing will also feature a live demo. So let's hope it works, because it might not work. It's going to be a demo with an LLM. So yeah, let's get into it. So let's maybe start with like, where is AI today actually delivering ROI? So I think we have a very good idea at our company, because we have several projects right now around different use cases with LLMs, and I'll showcase, let's say, three pillars in which we see the ROI today, and it's not chatbots. So we actually don't do chatbots for clients. I think, just from my personal perspective, chatbots are not the end solution for business clients. They're a great solution for, let's say, developers looking to automate code generation. But for business clients, they're not the best solution. And I'll show you today how you can implement AI in other ways, not just chatbots. So, as you probably all know, LLMs are the ultimate text machine. So Jan LeCun, earlier this morning, talked about how, in his opinion, we should focus on world models to reach AGI, and we're probably not going to reach AGI with LLMs. But I still think, from my perspective, that LLMs are a great machine for automating work that is based on text. So this is basically all knowledge work, in my opinion. And because of that, a lot of value can be created today with what we have right now. So we don't have to have world models to deliver a lot of value to businesses, to customers, to basically drive economic productivity. And once you can turn anything into text, you can automate. This is also my opinion. You can disagree with, but I found that once you can really turn anything into text, and you don't require, let's say, manipulation of objects in the real world, you can automate really a lot of stuff. And I didn't find anything I couldn't automate once I figured out how to turn it into text. And these are the three pillars I mentioned earlier. So these are like our main use cases, and they're very high level at this stage, and we'll delve deeper into one of them today. The first one, and this is the use case we started with back in, I think it was 2023, when we started with the GPT 3.5 API, was data structuring. So basically turning unstructured data into structured objects, which allowed a lot of automation. Then once we reached the level of GPT-4, which is expensive, but then we got new models, they could analyze documents, and they could really, really understand them. So this is what allowed another use case, which we call just document analysis. And then I would say early this year, when we got maybe the Sonnet 3.5, Sonnet 4 level of LLMs, we got models that are very good at agentic actions. And that's when we kind of maybe not discovered, but just enabled something called computer use automation. So for those of you who don't know what computer use automation is, it's basically having an agent, an AI agent, perform actions on a computer, just like a human would do, only slower, based on very similar input. So most of that stuff right now is based on the browser, because it's the easiest to implement. So you can think of yourself using a browser, clicking through websites, and instead of you having an AI agent just click through the website for you. So this is computers automation, and it's become possible, I think, early this year. And we already have one app running in production that is using computers automation for basically driving value for a customer, which I'll show you today. Okay, so this is what I already explained. So this is an LLM that can use a browser like a person. It opens tabs, searches, clicks, that's everything you do yourself in the browser, but does it without you, only based on textual input. So you say to the agent what you would like it to do in the browser, and it will do it for you. And it's already being implemented by the major labs. So there are a few products, mainly OpenAI Operator. It was, I think, one of the early ones. Now we have ChatGPT Atlas, a new browser by OpenAI. We also have Anthropic Computer Use. I think this was the maybe earliest one. We have Perplexity Comet and Gemini Computer Use Tools. So a lot of the big labs are already figuring out how to use this. But in my opinion, these products, for example, ChatGPT Atlas, they may be a little fad because they're very constrained to like a single flow. Because why prompt a model to, let's say, purchase something from a website when you can just click it yourself probably much faster without having to type in anything. But the technology that is supported by these tools really does make sense when you do it not in a single stream, but for very repeatable tasks in parallel. And I'll show you how to do it today. And also in practice, you can hire an intern made of tokens, because the models today, they're not very sophisticated when they do these things. They still make a lot of mistakes, but it's getting better and better. So you can think of computer using agents like this, just like an intern who doesn't have very deep knowledge of your field of work, of your company. But if you can specify your instructions in text, they would probably understand it, and they will be much cheaper than a human to run. So that's a great advantage. All right, so now for the particular use case that I want to present to you today, I will start with the client for whom we created this solution. It was a cosmetics brand, an e-commerce client, about 100 million euro in revenue. They're based in Poland, but they do business all around the world. And what they struggled with was finding new leads to sell their cosmetics products. And how they did it before we introduced the tool was they had an actual team of people, salespeople, who had an Excel file with about 300 keywords for very different languages, different markets, which they typed into Google regularly, like every few weeks, looking for new distributors. So either retailers or big wholesalers for the brands they had in stock. So you can think of the client looking to sell, let's say, L'Oreal shampoo, and they want to now find a new lead in Armenia. So they have a salesperson typing in the keywords into Google, L'Oreal Armenia, something in Armenian, and then getting the search results in Google, going through the websites, checking the websites, if the client is actually a good lead or not, collecting the contact information, and then contacting them. So this is what they did before. And they had a team of people doing this. So you will probably already see the use case for the tool we did. And so great people, but terrible use of their time, in my opinion. Just clicking through Google. Yeah. So this is the workflow. I just explained it. It's pretty simple, very simple work, but still has to be done. And we found a way to automate it this year using computer using agents. We asked ourselves a question: can we turn a sales team into a Python script? And the answer is absolutely yes, we can do it. So it was already an ongoing project for the client. So we didn't have to start from scratch with this idea. It was implemented as an add-on module for the whole system. And now this is how we did it. So this is a diagram. I hope it's not too extensive and difficult. So what we just require the client to do is input the brand that they're looking to sell and the market they're looking to sell the brand for. So Armenia and L'Oreal. And then what happens is we have a pre-generated list of keywords for every market. So this was already generated by AI beforehand. For every market, we have keywords for wholesalers or retailers. Then once we have that, we search the web, actually using the DuckDuckGo, using those keywords and the brand and the market. Then for every domain we get, we have a, let's say, a check where we use the computer vision agent to check if the brand actually is a good lead. Once the brand passes the check, the browser agent visits the website and collects contact information. So it decides if this is a good distributor or retailer, and if not, it discards the lead. But if yes, it collects the contact, the VAT information, the location, and then aggregates that data into a list of leads and also exports that into their CRM system. So what happens is, instead of having to go into Google with their manual keywords, having 10 people do it, let's say every few days, now they can say, okay, give me 100 new leads in Armenia for L'Oreal. They click start, and then sometime later, they just go into their CRM and they have the list of the clients. And now time for the live demo. So please hold your thumbs, it works. Yes, it's gonna be a command line demo. I'm gonna invoke it from the CLI. I had to modify the code a little bit. I'm gonna make it a little bigger so you can see. So now I run the service. I run it with L'Oreal for the French market, as we're in France, so kind of a local twist. And also right now I run it in headful mode. So what happens normally is when they submit such a, let's say, search, the app doesn't display anything. It just collects the leads. But I modified the code for this demo, so it will actually open up the browser, so you can see how the agent interacts with the websites. So what happened now is we just invoked the DuckDuckGo HTML with our query. You can see it there on the top. So it's a query in French for L'Oreal. I can't verify if it's correct. Hopefully it's correct. And now we get a list of websites. And what is happening now is browsers are being opened. So I'll just show you the browsers. So we have one here and 5 others in the background as well. The internet is a little slow here, so pardon for that. But you can trust me that 5 browsers are being opened right now, and the agent is gonna, okay, so we see we have one website here, another here, another here. So as you can probably see, they're all very different. Like, for example, this one has already displayed some probably cookies banner, and you have to click through it. So what is very powerful about this technology, and this is what made it possible for us to even implement this case, is it is generic. So it can work with any website. I would say maybe some website it won't work, but it should work for most websites, because what the agent will actually do, as I will show you right now, is it calls an LLM with a prompt that instructs it I can actually show you the prompt, I think. Yeah, so it just instructs the prompt that it's analyzing the company website, it should extract the email address, the phone number, and how to do it. So some tips where it could be located. And based on that, it's calling an LLM, and what is being fed into the LLM is first of all the prompt, then the text in the page, and also the screenshot of the page with highlighted clickable elements it can interact with. And what the LLM can do is invoke tools. So this is what makes it an agent, is it can invoke tools in turns. And those tools can, for example, be clicking on buttons, like accepting the cookie banner. And it will execute those steps until it reaches its goal. And the goal is to collect the contact information. And we can already see one is already done. So it's done. Yeah. So this is how the agent works. Okay, so I think this might be it for the live demo to not waste too much time. So let's get back to our presentation. So what the client gets in the end after the search is done, they get the type of the client. So this is their requirement, either retail or wholesale. The country, city, address, website name, email, phone, and registry info. So just for your reference, this demo was a little simplified in comparison to what the production app does, just to make it a little faster, because I didn't want you to wait a long time to get the results. So this is what the client actually gets in production. And the tech stack, if you're interested in that. Also, FYI, we didn't code the whole agentic workflow. We just implemented it for the client, and it's based on Python with Playwright, and we're using the browser use framework. And this is the framework, in my opinion, it's very good, might be the best for computer reading agents when it comes to open source frameworks. And right now we're using the GPT-5 Nano model, which is very cheap and it's very fast also in comparison with other models. But it's very easy to swap to another OpenAI compatible model, for example, Scaleway model. So this can also run on Scaleway. We use a DuckDuckGo HTML fetcher for the search, Pydantic for schemas, RabbitMQ as the pipelines, and Docker for the deployment. Yeah. It's opening up new web pages. Yes. Can this run on Scaleway? Absolutely yes. What it requires is an OpenAI compatible endpoint, but I think it also supports other providers, so let's say Anthropic. So the image input is optional, so it can also run based on just text, but you get much better results when we also feed an image input. So it's good to have a model that supports both image and text as input. For example, Scaleway has the Gemma 3, which supports both image and text input. And you can run, for example, the Playwright instances, so the browser instances on Kubernetes on Scaleway. So it's perfectly runnable on Scaleway, and I recommend a small multimodal model because it doesn't make sense to use a very heavy model in this, because this kind of task consumes a lot of tokens and also consumes a lot of images. So it definitely makes sense to use a smaller model and also break down the, let's say, full pipeline of tasks into smaller subtasks. So it's simpler for the smaller model to run. Okay, so now some takes from actually doing this in a production grade app for our client. So these kind of agents are very slow, and this is a fact. So when you create something like this, you have to take into account that once the user clicks the search, they will have to probably wait some time. So to get 100 results or 200 results can take even 1 up to 2 hours with the full checks and input. So what we do right now is we just schedule the checks and the searches to run at night, so the salespeople can just come into work in the morning and get the results already done. So they don't have to actually invoke anything, and it can all be run from schedule. And also, browsers are heavy. So when you're running this, deploying this, you have to take into account that you're gonna be running multiple instances of browsers, kernel browsers. So not everything can be done in parallel. You can, let's say, spawn 20, 30 browsers, and then you're gonna have maybe run problems on your machine. And also, I think the most important take from deploying this is use traditional methods if it's possible. It's like it's not good to do everything with a code with an agentic agent with an AI agent because they're slow, they're expensive, and you can do a lot of things with just traditional checks, traditional programming. Oh, so it's actually opening up something. One moment. No, wait. Let's get back to the slide. Yeah. No, no. I'll turn off the script. 1 second. All right. Now the script is off, and now we can go back. So sorry for that. All right. So we actually tried verifying the brand presence on the website using an agent, but it turned out it returned a lot of false positives, and it was expensive. So we just chose an approach where we just supplied extra additional keyword search using a search engine, and we get perfect results using a traditional algorithm, and we pay nothing extra for it because we just have additional traditional step. So if you don't have to use such agents, I recommend using traditional methods, but not everything can be done with traditional methods. Because as you just saw, all those websites are very different, and you cannot expect to code a traditional web scraper for every website on the internet. So if you, oh, okay, it's a disagreement here in the audience. But yeah, if you have to deal with so many complex UIs, it does make sense to use some this kind of agentic frameworks. So this is the third point. So agents are for the long tail of UIs. So if you have a lot of diverse, unpredictable interfaces you have to deal with, then it does really make sense to use them. But if you have a few websites that use it like repeatedly, it makes more sense to just create custom scrapers for them and not code them, code a solution that uses this kind of agents. But in this particular use case for our client, we had to deliver this kind of solution, in my opinion. Of course, if you have greater ideas, I'm really open to hearing them. So, of course, you can talk with me about that later. And also, the tech is very new. So, in my opinion, this kind of solution was enabled only this year with the models which support good agent capabilities, because this kind of solution requires a long sequence of steps for the model to execute. So just last year, it wasn't, in my opinion, possible, at least not on production level. Also, additional tip, don't write the browser interaction stack yourself. Doesn't make sense. Just use open source solutions. Browser use is my favorite. I think it's very good. It's very easy to plug in. In 100 lines of code, you can already get a working solution, and it's just gonna be fine-tuning the prompt to do what you want it to do. And also enforce the output structure. Don't allow the LLM to just output anything. Make sure it's a structured output to predict what can actually happen. All right. So this is it. I hope you enjoyed it. I don't know if you have time for questions. I don't see the host from up here, so I think you can ask some questions. Okay. I think you were first. Yeah.
What is your opinion about tools like N8N?
Sorry.
What is your opinion about tools like N8N?
Okay. N8N?
Yeah. So for
Yeah.
because maybe you can also build something like this with N8N.
Yeah. Probably yes. We haven't tried doing it for this particular use case. We plugged it in as an additional service for an existing app. So I think these tools are great, especially if somebody doesn't have coding knowledge. So yeah. Okay.
How much on average 100 leads cost for you to scrap them?
That's a very good question. So I don't have the statistics for 100 leads. I know we're paying a couple $100 per month for the whole system. So I cannot give you the answer for it because the system also supports other functions and we generate thousands of leads. But what I can assure you is it's going to cost less than a human. So that's what we wanted to do.
Have you encountered any issues with browser automation detection mechanisms?
So what we do, I don't know if you saw in the prompt.
Yes.
Yes, so we give an instruction that it can solve captchas and click through any browser verification mechanisms, and it doesn't. So we haven't encountered because we usually visit like cosmetics websites, so they don't have very sophisticated algorithms for detecting automation. So we usually don't encounter any kind of problems.
Does the model relies on like images and so on to pose the
Yes, yes. Browser use gives you an option to also take screenshots of the website. If you supply it with a model that can support images input, it will take a screenshot of the website with the clickable elements on it.
And have you tried like optimizing the speed of the navigation using proxies to block like useless resources like images, some JS, like stones?
We haven't, but I think the main like blocker in the current pipeline is just the time it takes for the LLM to respond with the reasoning and all the stuff. Okay, do we have time for a question? Okay.
If you compare this, for example, to the firewall, so something like not an LLM-based crawler, how big of a difference in the functions it's using this kind of technique?
We haven't tried it in this use case, so I can't answer that. All right, thank you.
Thank you, Eno.